Alrighty, class, I am going to go over section P3. This is about the Cartesian plane and graphs of equations. The first set of assignments is basically how to use the distance formula and midpoint formula, and those are just basic formulas. All you have to do is know what your x and y values are and plug it into the formula and be able to work with decimals as well as fractions. Okay, so you do want to check the back of the answer to see if they want the answer as a decimal number or as a fraction. Your job is to make sure that you get the simplified answer in the back of the book. Okay, so I won't be going over that part because I think it's quite easy. The other part is just constructing tables and graphing points on the xy plane. So we will skip that part, but starting with page 35, numbers 45 through 74, they are talking about the x and y-intercepts and testing for symmetry. So I'm going to go and show you how to do that, okay? So first of all, let's talk about the x and y-intercepts. If I give you a graph, like the blue line here, hopefully by now everybody knows that this point A is the y-intercept. And this point B is the x-intercept. These are two very special points that will allow you to graph the line of a linear function very easily, because there are the points where, for the y-intercept, it is the point where x is equal to 0, and you just have to solve for the y. And then for the x-intercept, it is the point where y is 0, and you just have to solve for x. Or I'll just leave that blank. Okay, so these are very special points. I know that in the past when you did math, you didn't look at those two as points, but in a high-level course, every time they give you an intercept, you should be thinking of it as a point, because that gives you a lot of information to move forward with the problem, okay? So that's basically your y, x, and y-intercept. So for example, in a problem, let's see, x and y-intercept. Well, I can't find a problem right now, so I'll make one up, okay? So for example, if I give you 2y plus 3 is equal to x, and I ask you to find the x and y-intercept, what you'll be doing is you could make a quick table like the following. Just say this is your x-intercept. Okay, so your x-intercept is where y is equal to 0, okay? And your y-intercept, I'll put it down here, is the point where your x is equal to 0, okay? Actually, you know, let me redo that because I want to make sure that you understand where this is coming from, okay? So I just need to organize my work a little bit so you can follow through, okay? So again, okay, so x-intercept and y-intercept. Again, there are 2 points, okay? This is the x value, that's the y value. So your x-intercept is the point where y is equal to 0, and your y-intercept is the point where your x is equal to 0. So you're looking for those 2 points. Now what do? What you do is you go to your equation, the one which is given to you, and you let y equal to 0, and you solve for x to get the x-intercept, okay? So that's 0. So you see that this is the point 3, 0. That's your x-intercept. You go back to the same equation, and now you let your x be equal to 0, and you solve for y, and that's going to give you the y-intercept, okay? Oops, my x is here, so I'm going to go ahead and replace my x with 0, and then I need to solve this equation. Okay, so my y is going to be negative 3 over 2. Negative 3 over 2. Once we have those 2 points, you can graph them, and that gives you the graph of the line y, 2y plus 3 equal to 0. So x and y-intercept is pretty straightforward. Again, hopefully this is a nice review from Algebra 1 for you guys, okay? So the next part that I'm going to talk about is, you know, what are lines of symmetry, and what are you going to do to test for them, and how do you know, all right? So I'm going to go ahead and erase this part here. I went to Desmos, and I I graphed 3 graphs for you. I graphed the quadratic function, okay, basically a parabola, y equal to x squared. I graphed the equation x equal to y squared, okay, that's your parabola opening to the right, and I also graphed 1/4 x to the third, which is your cubic function, okay? So here, first of all, let's talk about the graph first so you understand what we mean by symmetry, and then I'll show you how do you check for symmetry if you are given an equation, okay? So here you have this line, and I'm going to use highlight here. You have this red line here, which is your parabola, okay? This is your y equal to x squared. All right, basic quadratic formula here. Okay, where is the line of symmetry? The line of symmetry is the line that goes right through the graph so that on both sides of the line you see the same thing, okay? So the line of symmetry for y equal to x squared is this dashed line right here that goes right through the vertex, okay? You guys all know that from Algebra 2. This is called your axis of symmetry, okay? Or what do they call it? Abdul, what's the line that goes right through the vertex?
The line that goes through the vertex?
Of a parabola. I can't think of the word right now. Oh, axis of symmetry. Okay, so they don't call it line of symmetry, they call it axis of symmetry. You remember your AOS? Okay, axis of symmetry. And that equation for your quadratic equation is actually x equal to minus b over 2a. Okay, I think you guys remember that from Algebra 2. So that's how you can find that line, but that's not the focus of this lesson. So I'm just going to go ahead and erase it, but this is just background information, okay? So that line is your line of symmetry. For a parabola, it is the axis of symmetry, okay? And if you notice, all the points on the right-hand side, you see these points here? They are equidistant from the line of symmetry, okay? Same thing directly opposite of it. Okay, so you see basically the same thing on this side, on the left side of the line, and you see the same thing on this side, okay? When a graph looks like this, we say that this graph has symmetry about the y-axis, okay? And we've noted by that curved arrow, okay? So the parabola opening up, or basically a basic quadratic equation opening up, is symmetrical about the y-axis because on both sides of the y-axis, you see the same thing, all right? I'm going to go quickly erase that. Now let's take a look at your x equal to y squared, okay? Your x equal to y squared is a parabola that opens to your right, okay? It's actually this one right here, okay, with the vertex of 0, 0 for this particular problem. It is this blue line, a blue graph. Okay, so as you see here, you can totally see that this line is, or this graph is symmetrical about your x-axis, because to this top and to the bottom of that axis, you have the same thing on both sides, okay? You see that graph, every single point corresponds to the same distance as the point on the other side of the axis of symmetry. So this function x equal to y squared, we say that it is symmetrical about the x-axis, all right? Then we're going to take a look at your cubic function now, which is that orange one. Okay, so this is the cubic function. Okay, so this graph is symmetrical about the point 0, 0. Okay, if you look here, notice this point A, and I'm going to give you this point B. Okay, notice that the coordinates of A is actually 2, 2, and the coordinates of your B is actually -2, -2. Okay, so notice that both the x and the y values have changed signs. Okay, that is going to give us a basis for how to check for symmetry. Okay, so this is just numerical answers. I want you to see the graphical examples first. Now we are going to go and put points on the graph that we just went over, so you see what's happening. Okay, all right. Just quickly erase that. So I didn't put points on the parabola opening upward, but if I did put a point right here, you will see that this is the point at -1, 1. Opposite of that is the point 1, 1. Okay, this is the x value, that's the y value, this is the x value, this is the y value. So you will notice that a function or an equation is symmetrical about the y-axis if you replace your x by -1 and you get the same function back. Okay, so the value in question is this one right here. Okay, the x value. Okay, so when you put an x, a negative x into x, you get the same equation back. All right, let's do the same thing with your parabola opening to the right. Okay, so right here for the blue line, okay, this graph here, if I go and I put a point down, maybe let's just, yeah, we're gonna be easy here. Okay, let's take a look at that one. That's the point 4, 2. Directly below that, you see the point 4, -2. So for this one, the y value in question is the y value. Okay, so basically an equation is symmetrical about the x-axis if you replace -y by, if you replace y by -y, and you get the same function back. Okay, and then the same thing is true with the cubic. But enough explaining, let me go and show you a few problems on how to actually show your work and how to actually test for symmetry. So I'll do the problem 3 times and I'll check for symmetry about the x-axis, about the y-axis, and also about the origin. Okay, the point is 0, 0. All right, so let's go to your homework problems where they ask you to do that. And by the way, this is directly from your book. Okay, this is from page 32, how to test with symmetry. They have some examples in there for you too, and the explanation of what you need to do. All right, so I'm gonna go to your homework problems. I am just going to do one for you, okay, because I don't want this video to be too long. This is problem number 59. Okay, so when you do your homework, make sure that you are doing the same way that I am doing it here, so that I can follow your work. Okay, all right. So testing for symmetry about all three, the 2 axes, and also the point 0, 0. So first of all, tell me which one you are testing. Okay, so tell me that you are doing symmetry about the x-axis. I'm ahead of myself, so I'm writing things not as I said them or say them. Okay, symmetry about the x-axis. Okay, so to do this, you replace the y by -y, okay, and see if you get the original equation. Okay, so this is the original equation, and I like to just write it down. Okay, so here you go. X squared minus y is equal to 0. Let y be -y and see what happens. Okay, all right, so in the same problem, x squared, there's a minus sign here, so be careful. I'm substituting -y in here. Okay, so I'm going to do the math. Negative times negative is positive, and this is what I get. Okay, so the original equation is this. Okay, my final one after I do the substitution is this. Okay, the question is, are they the same? If they are the same, then this equation, or this, whatever you call this, is symmetrical about the x-axis. Okay, if they are not the same, then there's no symmetry about the x-axis. So if you look at the original equation and you look at the equation that you get after you do the substitution, they are not the same. Okay, they are not the same. All right, so if they're not the same, then your answer is there is no symmetry about the x-axis. And because you've already written up there, you don't have to write it down for me again. Okay, now let's go to the second part. Now remember, for each problem you have to do 3 parts. Okay, all right, let's go and copy down the original problem again. I know it's a lot of writing, but that's what you need to do to make sure that you really truly understand these. And by now you know that, oops, I forgot one crucial point. I forgot to tell myself what I need to do. Now I'm checking for symmetry about the x-axis, y-axis this time. Okay, now I can write down my equation. That's the original one that is given to me in the book. Now I'm going to let my x be equal to negative x. I'm going to do my simplification and see if I get the original equation back. Okay, so I'm gonna go ahead. I always use parentheses for my negative numbers. You should do the same thing too, because if you don't, sometimes you will overlook that negative sign and make a mistake and you have to do the problem all over again. All right, now let's take care of the math. You know that a number squared is equal to itself. So here, let's compare the original equation and the one we just got. And are they the same? What is your answer to this? The answer would be yes. So therefore, your answer is there is symmetry about the y-axis. Okay? All right. So that's the second part. Third part, let's also check the symmetry about the origin, the point 0, 0. Okay, all right, original equation. And now we need to let x and y be equal to negative x and negative y. So you do both substitution, okay? And again, do the math and see if you get the original equation back. All right, so negative x squared minus a minus y. Notice I'm putting all of those in parentheses. This is going to give me an x squared. This is going to give me a positive y equal to 0. There is nothing else that I can do, so it's time to compare these two equations. And are they the same? The answer is no, not the same, because the y in the original equation has a negative sign and this y that we just got has a positive sign. Okay, so because they are not the same, there is no symmetry about the point 0, 0. Okay, so this is one problem where you have to check for symmetry. Again, one single problem, you must check for symmetry about the x-axis, the y-axis, and the point 0, 0. So you're doing the problem 3 times. Okay, so there you have it. This is for page 36, problems 45 to 74, x and y-intercept, and testing for symmetry. Bye.